Discretionary, optional transitive,
Very,
optional non-transitive.
very good. These are the types of attributes, not BGP attributes. There are 4 types of attributes in BGP, or you can say the first we categorize attribute into 2 part, well known and optional, and
Optional.
then both are categorized into again 2 part, right? So total we have 4 types of attributes in BGP. Okay, is my screen visible,
Are you
guys? Oh,
no, not visible. Your screen is not
wait,
visible.
1 minute. Now it's visible, right?
Yes,
So
it's
the first
visible.
thing which should come in your mind when I am saying attribute is best path selection. That how router is going to select best path. BGP uses attributes for best path selection, and we have total 4 types of attributes, or we can categorize attributes like this: attributes, and then I can say there are first 2 types of attributes, BGP attributes. First one is well known and second one is optional. Well known and optional. And after that again we categorized both into 2 part, well known and optional. Well known means, well known, what is the meaning of well known? Which are known for all the BGP routers, the attributes which all the BGP routers understand, right? The attributes which all the BGP routers understand. After that, well known is categorized into again 2 part. First one is mandatory. Mandatory means the attributes which will be always there in your BGP update message. Guys, how BGP will share the attributes? Through update message. In the update message, it will share the prefix and attribute. So the first is mandatory. Mandatory means mandatory attributes are those attributes which BGP always carry in their update message. The attributes which BGP always carry in their update message, mandatory. And the second one is discretionary. Discretionary. Is the spelling correct? You can see, check the spelling. Is the spelling right, guys? Discretionary. Okay. And then optional. Again, optional are categorized into optional is categorized into 2 part. One is transit and transitive, and another one is non-transitive. Transitive and non-transitive. That's why I'm saying there are 4 types of attributes. Okay, transitive, non-transitive. Now let's understand these attributes type first. After that we'll see the all attributes with their sequence, like which attributes will be checked first by router, which attributes will be checked after first, then so on, like that. Okay, so if I am saying there are 4 types of attributes, that means one is well known mandatory attribute, first one. Second one is well known discretionary attribute. Third one, well optional transitive attribute, and the fourth one is optional non-transitive attributes, right? So whenever anyone is going to ask you how many types of attributes are there in BGP, so you will say 4 types of attributes are there in BGP: well known mandatory, well known discretionary, optional transitive, and optional non-transitive. Is it clear? Clear, guys?
Yes, sir.
Yes, very good. Now, mandatory
Right,
attribute. What I told you, what is mandatory attribute? The attributes which BGP will always carry in the update message, right? BGP will always adds in update. BGP always adds these attributes in the update message. We will see which are the mandatory attributes. Mandatory attributes are next hop attribute, ES path. You have seen the ES path attribute in previous classes, right? So that is what ES path is, one mandatory attribute, or you can say well-known mandatory attribute. Means the ES path will be always and always there in the BGP update message. Okay, ES path, then next hop, then origin code. These are the mandatory well-known BGP attributes. Second one is discretionary attribute. So guys, sometime BGP is going to include these attributes in their update message. Sometime it will not include it in their update message. Right. The another thing which you need to understand about these types of attribute is like well-known mandatory attribute will be always here to always include in BGP update message, and every router must understand this attribute, right? Every BGP router must understand the mandatory well-known attributes. After that, well-known discretionary attribute. Again, every router should understand these attributes. This is your local preference aggregator. These attributes are called discretionary attribute. Sometime BGP will share it in the update message, sometime it will not include in the update message. Then transitive. Transitive, you can add this attribute, right? If you want, you can add this attribute in the BGP update message. Okay, and can anyone tell me the non-transitive attribute?
If not understand by router, then it will discard this.
Yes, the difference between transitive and non-transitive is, see, if a BGP router is receiving a update message with transitive attributes and a router does not understand that, then also router will pass it, forward it to their neighbor. But if there is non-transitive attribute in the update message and BGP cannot understand it, then BGP will not pass it to their neighbor. This is the major difference between transitive and non-transitive. But no worry if BGP cannot understand the transitive and non-transitive attribute. But mandatory and discretionary, these attributes are the attributes that every router must understand. Okay, so again I am repeating, well-known mandatory attribute must present in every BGP update message and every BGP router must understand them. If these attributes are missing in the update, if router is receiving any update message and this mandatory attribute is missing, well not mandatory, then router will discard the update message. It will reject the update message. And the example of this mandatory well-known attribute is ES path, next hop. We will discuss these all attributes one by one in detail. ES path, next hop, and then origin code. Origin. These are your well-known mandatory attributes.
Local preference.
Local preference. No, local preference is not well-known mandatory attribute. Local preference is discretionary attribute. Yes. Yes. ES path. What is ES path? It is nothing but the list of your ASs. ASs that route passed through, route coming from how many ESAs, number of ESAs, list of ESAs. Next hop means the IP address to reach destination. Origin code, we'll see the origin code. There are three types of origin code. It is like how router learn this network, this prefix. There are three types of origin code. We have IGP, EGP and incomplete. We will discuss all. After that, well known discretionary attribute. So may be or may not be present in the BGP update message. May be or may not be present in BGP update message or in the BGP update. That is also BGP, right? But if it is present, what I told you, but if it is present, then every router must understand it. If it is present, then every router must understand this attribute. If it is present, then every router must understand it. An example of discretionary attribute can be your local preference. Local.
But this dictionary one is added manually, I think, isn't it?
Not manually. You will see when it will be shared to in the update message, right? Local preference, which tells route is preferred inside an ES. Don't worry about the meaning of local preference. We'll see. We will be manipulating the path by using these attributes, local preference attribute, and you will learn more about this attribute. This is one example of well-known discretionary attribute. So what I told you, maybe BGP will include this attribute, maybe BGP will not include this attribute. You are not going to add it, right? You can also add it, but by default also sometime router will add, sometime router will not add. You will learn when it is going to share the local preference, when it is not going to share the local preference. But if this attribute is present in the BGP update message, then every router should understand it. Let's say one router is sending local preference value in the update message and their neighbor router does not understand the local preference. Then guys, it will discard the update message, right? So every BGP router must understand these two types of attribute, mandatory and discretionary. Clear? After that,
Yes,
optional transitive attribute. Guys, this
sir,
is
one
not, yeah,
one in discretionary means all router must be understand this.
yes, yes. Sometime router will send, sometime router will not send this attribute in the BGP update message. But if router is sending, if this attribute is present in the update, then all the router must understand it. After that, optional transitive attribute. This is not mandatory attribute. If one router does not understand it, no problem. It can still forward it to the next router. It can pass across the ES. And here we have some attributes. First of all, I can say not mandatory. And attribute is your community. Community is like a tag, right? Tag or label. You will learn more about the community in future class. It is like tag used to configure policy. For the policy only we will use the community, right? Or there can be many scenario where you need tag. And the second attribute is aggregator here. Aggregator. These two are optional transitive attribute in the BGP, right? It is like tag. Aggregator means when you will aggregate the prefix, when you will perform summarization. In that case, BGP will send this attribute. Aggregator means who is summarizing the prefix. We'll see it. The last one is non-optional, non-transitive attribute. Again, this is not mandatory attribute, means BGP can understand or maybe it cannot understand, but here router will not forward it. If router will not understand it, then router will not forward it. And example of non-transitive, optional non-transitive attribute is your MAT. MAT is exactly similar like metric, multi-exit discriminator, and then originator ID, or we can say originator ID or cluster ID, cluster list. Sorry, cluster list.
See, yes, sir. It should be cluster. It's like cluster now.
Yeah, right. So we will talk about these all attribute: AS path, next hop, origin code, local preference, community, aggregator, made, origin code, and cluster lists in detail. But these are the types of attributes, and hope it is clear.
The cluster list should be C, not G. Should be cluster list. C.
Yes, sir.
Oh, okay.
A cluster list means we will group it, we'll club it.
Yes. Made, originator ID, and cluster list. Now, if I will talk about the checks of these attributes, like how BGP routers are going to check these attributes for best path selection, right? So guys, for that you need to keep in mind 12 attributes in this sequence, right? In this sequence, see, the first attribute is your next hop attribute. Next hop IP address should be reachable. Then wait, again wait is one Cisco proprietary attribute. You will only find this attribute on Cisco devices. You can see here I have not mentioned the wait attribute, right? And we'll see what is that wait attribute. Then it is going to check local preference attribute. Then it is going to check self-advertise prefix. Self-advertised prefix will be always prefer over received route. This is best path selection. Here I can
This is
mention
locally originated, same, sir.
best path. Wait, brother, 1 minute. Best path selection. 1 minute, sir. Best path selection in the BGP. Let me write the attribute, then you can ask. Self-advertise. After that, your AS path attribute will be checked.
Sure.
And then origin code will be checked. Origin code. After that, external over internal. External prefix. You know the external prefixes has what AD value? 20, and internal prefixes has what AD value? 200. So external will be always before our internal. And between origin code and external, we have one more attribute, that is made, right? After origin code, it is going to check made, and then external over internal. And after that, see, IGP cost to reach next hop. IGP cost to reach next hop means, let's say your IGP protocol is OSPF, then OSPF cost to reach next hop. IGP protocol, it can be OSPF, EIGRP, and RIP. IGP cost to reach next hop. After that, oldest path. And see guys, if you want load balancing in BGP, then attribute till here should be same. If these all attributes are same, then only you can achieve load balancing. This is the tiebreaker. Wait 1 minute. Let me check all these attributes. Okay, good. So if all the attributes still here are same, then you can achieve load balancing. But what I told you, by default BGP does not support load balancing, right? By default BGP does not support load balancing. So even if all the attributes till IGP cost to reach next hop are same, then also BGP cannot install more than one path in their routing table. Then what are the tiebreaker for best path selection? That is going to be, guys, oldest path. What? Oldest path. Your old friend will be always best. Oldest path. Oldest path for eBGP neighbor only. This attribute will be checked for eBGP neighbor. For eBGP only. If it is IBGP, then it is going to check lower neighbor router ID. Lower neighbor router ID. Right, and you know router ID is unique. Two router cannot have same router ID. But if we have multiple links, two links between two routers, then again router ID can be tie. For example, for an example like this. For an example, R2, R1. And here I have one subnet X. And two links are there. Router ID of this router is 2.2.2.2. And we are running BGP. BGP here on this link also, BGP over here also. We have two neighbor in BGP. So router 2 is going to advertise X submit to R1 over both link, and router will select one path as a best path. Router can only install, R1 can only install one path in their routing table for X, the best next hop. So it is going to check these all attributes in this sequence from top to bottom. And in this case, you can see router ID will be also same. Router ID will be also same. Then if router ID is also same, then next attribute for IBGP only. For IBGP neighbor is lower neighbor router, IP address. Lower neighbor IP address, which can be neighbor same, which will be always unique. So these two are for IBGP, tiebreaker for IBGP, and this is the tiebreaker for eBGP. Clear? By
Yes, sir,
default,
it's clear.
BGP does not support load balancing, right? So here are, you can see three tiebreaker. One, oldest path for eBGP, and for IBGP we have these two attributes: lower neighbor router ID and lower neighbor IP address. And it means BGP is going to share these all attributes in their update message. In their update message.
Sir, for IBGP loopback IP also comes in the picture.
Means loopback IP means
Means, sir, if the router ID and IP, which will the preference means will be given for the selection of the path? Means if
Yes,
the
yes,
lower
I
neighbor.
think so, sir. He's trying to say that lower the IP on the router. So if
Right.
the loopback will have the lower IP address, whether it can consider the path selection process like.
I didn't get it. Means let's say two
So in
routers are
the
there.
If we have neighborship with the loopback, he is trying to say. So if we have loopback, and then how the tie will be happen? It will be preferred by loopback, right?
IP address, neighbor
Yes.
IP address, how to reach loopback.
No, yes. So suppose we have loopback neighborship, then it will prefer loopback lower IP address, right?
Yes. So if you have two neighbor here, let's say on router number 2, two loopbacks are there, 2.2.2 and 3.3.3. If you have only one neighbor, then how it will perform the best path selection? That path will be, if there is only one neighbor, 2.2.2, there is only one neighbor, so only one neighbor will advertise the prefix, na? With the help of loopback, here I have loopback 2.2.2, here loopback 1.1.1.1. So guys, we will have only one BGP session between 1.1.1 and 2.2.2, na? So only one path is here.
Here, loopbacks are there for forming the neighborship, not for the best path, no sir. Best path for
So router,
we check
you are
the
saying
best
that
path
router
for
will receive
routing.
prefixes from two neighbor. Here R1 will receive prefixes X subnet from two neighbor. R1
No.
and R2. And let's say R2 is connected to one subnet X. So only 2.2.2 will advertise prefix to R1. It will not perform load
Yes.
balancing here.
No,
Even there is
Gautam was
no
asking, right?
two neighbor. Best path selection will happen when router will receive same prefix from multiple neighbor. Okay? If there is only one neighbor, there is no best path selection. Clear, guys?
Yes, sir. Yes.
Okay.
Okay. Now, let's start with first attribute, which is next hop. Next hop attribute means next hop IP address should be reachable. Next hop. For an example, I can say I have one topology like this: R1, R2, R3, and R4. R1, R2, R3, and R4. On router number 4, let's say I have one LAN subnet. Which LAN subnet? 40. 40 ले लूं 40.1.1.0/24. Done. Now you are running BGPS number 100 here, BGPS number 100 here, let's say 200 here. These are service providers. R2 and R3 are service provider, and these are my two different sites, branch 1, branch 2. And in branch 1, here we have BS number, for an example 200. Now tell me, when router 4 will advertise 40 submit to router number 2 and router number 3, what will be the next hop? 24.24 is the IP address here. 24.4 is 34.4 is the IP address here. 34.4 IP address over here is 12.2. IP address over here is 13.3. Yes. When router 4 will advertise 40 submit to router 2 and router 3. On router number 2, what will be next hop? 40.1.1.0/24. Next hop. Reachable via 24.1.1.4.
24. Yes.
On router number 3.
Same.
Same.
34.1.1.4.
Yes.
When router 2 and router 3 will advertise it to router number 1. When router 1 will receive 40.1.1.0/24 subnet from router number 2, what will be the next hop?
It will be the same because it's IBGP.
24.1.1.4.
4. Yes.
And from this side?
So 34.1.
1.4. Yes.
34.1.1.4. Now, can router 1 forward traffic to 40 subnet? Can router 1 forward traffic to 40 subnet?
No.
No, sir.
Because next hop is not reachable. If next hop is not reachable, these prefixes are only valid, not best. If prefixes are not best, then router will not install it in routing table. Guys, getting noise from somewhere. Please put yourself on mute if you are not speaking. तुमको कौन बोल रहा है भाई? Clear? So guys, what I am saying that do something so that router 1 should forward traffic in 40 subnet via router number 2. Right? I am asking you, I am telling you to update the next hop IP address on router number 2. So what you will do, you will run command IP next hop self where on router number 2. Also will run IP next hop self command for router 1 on router number 2. It will start sending their on next hop IP address 12.2. 12.2. So from router number 2, next hop IP address is 12.1.1.2 now. 12.1.1.2, and from router number 3, next hop IP address is 34.1.1.4. So best path will be via router number 2. In the routing table, you will find this subnet is reachable via I2. Is reachable via I2. It will install one path in the routing table, and this is how on the basis of next hop attribute it can perform best path selection. On the basis of next hop attribute, how it can perform best path selection. And now if I am going to run next hop self command on both the routers, router 2 and router 3, then from this side also next hop IP address will be what?
13.3.
13.3. And now you can see both the next hops are reachable, and if both the next hops are reachable, then router will check next attribute for best path selection. Now here on the basis of next hop attribute, it cannot perform best path selection. Yes or no?
Yes, sir. Cannot.
Yes.
Clear, guys? Now next attribute is what? Now it is going to check wait attribute. Let me tell you about wait attribute first. Let me open the another page. And what is wait attribute? Wait. So wait is Cisco proprietary attribute. Cisco proprietary means we will find this attribute only on Cisco devices. Cisco attribute. It is Cisco attribute. And BGP never carry this attribute in the update. BGP never carry wait information in the update message. BGP never carry wait attribute or wait information in the update message. Okay, so it means here the routers, router 1 and router 2 will not receive any attribute for 40 subnet. Router 1 will not receive any attribute for 40 subnet. Wait attribute is locally significant. It is locally significant. If you want the best path selection here, you can use the wait attribute. If here I will configure wait 10, right, automatically upper path will become best path, right? So we can control the path on the basis of wait attribute here. By default, wait for both the neighbor is going to be 0, 0, because BGP is not going to carry it in the update message, right? It will not receive any wait value for 40 subnet. It is local to the router. Local to the router. But we can use wait attribute for path manipulation, to control the traffic, to control the path. For self-advertised prefix, for self-advertised prefix, wait is 32768. Okay, so here in this case weight value on router number 4 for this subnet 40.1.1.0 will be what? 32768, right, for self-advertise. But it will not advertise this weight attribute to their neighbor. So on router number 1, weight value for 40 subnet will be what? 0. On router number 4 also 0. On router number 1 also what will be the weight? 0. Right? Means for any received route, for received prefix, weight will be always 0. Okay, and higher weight value will be always preferred. This is my weight attribute on Cisco devices. For an example, R1, I have one router here, R2 and R3. Both the router R2 and R3 are, let's say, advertising one subnet. Are advertising one subnet 10.1.1.0, let's say R1, R2, R3. Both the routers are advertising this 10.1.1.0/24 prefix 10.1.1.0/24. Done. So first router will check router 1, when router 1 will receive these prefixes from both the neighbor, this prefix from both the neighbor, it is going to check next hop. Let's say here I am running ES number 100, 100 and 200, right? So next hop IP address will be R2 and R3 exit interface IP address. Both the next hop IP addresses are reachable, right? Means at first attribute next hop, both the path are best path. Then it is going to check weight will be 0. Now if you want to prefer router number 2 or router number 3, you can configure weight. I can tell to router number 1 that set weight value 100 for router number 2. Or I can do one thing, I can create one route map here on router number 1. You know the policy configuration through route map. I can create one route map with name, let's say Cisco, with name Cisco, and in this route map I am going to say set weight value what? 100. And after that in the BGP I will apply this route map with neighbor 12.1.1.2. in which direction? Route map 12.2 route map. Which route map? Cisco. In which direction? In direction, right? Now whenever router 1 will receive any prefix from this neighbor, it will set weight value what? 100, right? And router 1 will start preferring router number 2 over router number 3. Is it clear? Guys, weight attribute will manipulate which type of traffic? There are two types of traffic, inbound traffic or outbound traffic. It is manipulating which type of traffic?
Outbound.
Inbound, sir.
Is manipulating
Which type of
outbound
route?
traffic.
If I am saying traffic, that means I am talking about packet, user data. So it is manipulating outbound traffic. See, like here I have one user, guys, whose IP address is, let's say 1.1.1.1, and this user is going to ping 10.1.1.1, right? So user will forward traffic to router number 1, and router 1 will check their routing table. In the routing table, best path is via router number 2 because of weight, so it will forward traffic to router number 2. So we are preferring the route via router number 2, and my traffic is then going via router number 2. So if I will talk about the route, so we are influencing the inbound route. Which route? Inbound route, the route which is coming on router number 1. And whenever you will manipulate the inbound route, the effect is going to be what? on outbound traffic. In outgoing traffic, effect will happen for outgoing traffic, for the traffic which will go from inside to 10 subnet. Right?
Sir, please repeat this.
Sir, if suppose so one down.
Yeah.
So if we have the R1, if R1 towards R2, I am keeping as 100 of the value of weight.
Okay.
So and my route map is pointing to inside.
In direction.
In direction.
In
Yes,
odd
sir.
direction, even if you will apply, then also it will not work because BGP is not going to carry it. BGP does not carry the weight attribute in update. So on router number 2, it will be 0 only.
Okay, sir.
We can not influence the outbound routes through weight attribute. Weight attribute is used to influence inbound routes, the routes which are coming on your router. And if you are influencing the inbound route, means you are manipulating the outgoing traffic. Right? Like these are, let's say, service provider, 2 service providers, and here you have another side somewhere, right? And from this side you are you have one LAN submit 10.1.1.0/24. So if you want to forward the user traffic via ISP1, this is ISP1, ISP2. If you want to forward the traffic via ISP1, right? Let's say this is in Delhi and this is in, let's say, Dubai. So if I want to forward traffic from Delhi to Dubai via ISP1, then I will influence inbound route on router number 1. And to influence inbound route, we can use weight attribute. Weight attribute will only work in direction. That's why I'm saying through weight attribute, you can only influence incoming routes, which will influence outgoing traffic. Right? If this 10 subnet will be based on router number 1 via ISP1, then user will access these servers via ISP1. If the route is based via ISP2, then my all traffic will go via ISP2. Right? So if we are influencing inbound route, that means we are controlling the outbound traffic. Right? And let's say here I have one subnet 20.1.1.0/24. What I want, that whenever anyone from the Dubai want to access the server in Delhi side, the traffic should come via ISP1. So this time, guys, see, I am trying to influence incoming traffic. So I will control outgoing route. In the BGP, your task will be what? Controlling the outgoing route. Right? So you will try to advertise higher weight value from to the ISP1 than ISP2. But we cannot achieve it through weight attribute because BGP will not carry it. But if I will talk about the local preference, so BGP can carry the local preference value in the attribute, and local preference, higher local preference will be always prefer. So what I want to receive my traffic from Dubai to Delhi via ISP number 1. So from I will advertise some local preference value, higher local preference value to ISP1. Right? So when the Dubai side router will receive the routes from ISP1, it will have higher local preference value. Here it will have lower local preference value. So best route will be via ISP1. So whenever user will forward the traffic, my router will route the traffic towards ISP1. Right? So in BGP, you are going to control, you are going to influence, you are going to manage 2 types of routes: inbound and outbound. Outgoing traffic and incoming traffic, or outgoing route or incoming route. So we will have 2 requirements, that maybe sometime from Delhi side to Dubai side, you want this path. From Dubai side to Delhi side, you want this path. Right? So requirement can be anything. And we will create so many requirements, and we'll see how we will use multiple attributes together. But guys, we have so many attributes, and all attributes has their on a specification, right? Like weight attribute is used to influence outbound outgoing traffic. It is used to influence outgoing traffic or incoming routes. It is used to influence incoming routes only. Okay. Now let's say here I have not configured any weight attribute. Forget about weight. So weight will be 0 from both sides. Now weight attribute is also same. Now router will check which attribute for best path selection. Now router will check local preference value for best path selection, because your next attribute is local preference, you can see, right? Any question in the weight? Now if anyone have question till here, you can ask. Understanding the BGP attributes so important. So if anyone have any question, please ask if anything is not clear to you.
Sir, one query. I didn't get this. So R4 you mentioned as 24.4, right? What is the exact IP that you are referring there?
24.0.0.4, 24.100.100.100.4, 24.255.255.255.4, anything. Instead of 24.4, I can also say A or B or X or Z.
It's the last
I
slide.
mean, you are
If
referring
we
as
go
24 is first acted, 4 is last acted. Is that?
I am preparing 24.1.1.4 here.
Okay.
This is the IP. 24 is the first octet value and 4 is the last octet value. Okay, like 10.1.1.1 is equal to 10.1.
Yeah, I understood. Okay.
Yes. Next.
so last slide. Can you go that again?
Okay, last slide. Here it is. Yes.
So as from the outside, I understood, sir. If suppose from the R1 we have the some LAN segment as of 40,
Okay.
and I want to achieve my R2 has a greater bandwidth, so I want to achieve from the R2 only. So how I will influence that time?
You want to receive traffic for 40 subnet via router number 2, right?
No, I want to suppose my R2 side, my data center also there. I want to
Yeah,
advertise
here
it.
is your data
So it is,
center and you want to receive traffic from data center to 40 via router number 2.
yes, sir. Yes,
Right?
exactly.
That means you have to advertise better routes via router number 2, which is
Yes,
not
correct.
possible through weight.
Acha, which is
So
not
what you will do,
not
you
possible.
will configure local preference higher, you will advertise higher local preference value to this neighbor than this neighbor,
Okay, okay, sir.
right? So local preference value is used to influence incoming traffic or outgoing route. Like weight attribute is used to influence incoming route or outgoing traffic. Local preference attribute is used to manipulate incoming traffic or outgoing route. It's opposite. Okay. Even local preference value can be used for both types of control, both types of manipulation, but generally in most of the cases we are using local preference for incoming traffic, right? Let me tell you about local preference attribute now, if it is clear. Yes guys, any other question? Do you want to see the weight attribute configuration first?
Sir, next stop configuration.
Next stop configuration, let me show you.
Yes, sir.
sorry, 12.1.1.1 255.255.255.0 exit interface f1/0 no set and IP address 13.1.1.3 255.255.255.0 exit router BGP AS number, let's say 100, and neighbor 12.1.1.2 remote AS of neighbor is, let's say 100, and one more neighbor 13.1.1.3 and a remote AS of this neighbor is also 100.
Sir, 13.1.1.4.
4.
Hmm?
13.1.1.4.
Router 3 IP address 13.3 na 13.3 copy and let me paste it on R1. कहाँ पे गलती हो गया यार, कॉन्फ़िग मोड में नहीं गया. Okay, so here my IP address is 12.1 means 12.1.1.1. Here my IP address is 13.1. Here my IP address is 13.3. Here my IP address is 12.2. Here my IP address is 24.2. Here my IP address is 34.3. Here my IP address is 34.4. And here my IP address is 30.
No, it's wrong.
Yeah, it's 24.4. This is my IP configuration. So you can see the configuration. It's correct, na?
Sir, in R1 for F1/0 13.1.1.1.
Okay, IP address is incorrect. Yes. Let me copy and let me paste the command again. Now done. For router number 2 on F0/0, my IP address will be 24.1.1.2, and on F1/0 it is going to be 12.1.1.2. One neighbor is going to be 12.1 and one neighbor is going to be 24.4. 24.1.1.4, and remote AS over here is let's say 200. On router number 4 I am configuring 200. Let me copy and let me paste these commands on R2. Then R3 and R4. For R3, IP on F0/0 will be 13.1.1.3, and here it will be on F1/0 it will be 34.1.1.3. Neighbor is going to be, one neighbor is 13.1.1.1 remote AS 100 and another neighbor is 34.1.1.4 and remote AS is 200. Okay, good. Copy and let me paste it on R3. Then on router number 4, F0/0 IP address will be 24.1.1.4 and here IP address will be 34.4. One neighbor will be 24.1.1.2 whose remote AS is 100, and another neighbor is 34.3 whose remote AS is also 100, and here BGPS number is 200. Let me copy the command, and one more thing here, I need one loopback interface, loopback 1, and IP address, let's say 40.1.1.1 255.255.255.0, and I am going to advertise this network in BGP network 40.1.1.0 and mask 255.255.255.0. Is configuration clear to everyone? Hello.
Yes, sir.
Yes.
Yes, sir.
Okay. Now here see on router number 1, so IP BGP summary. Very good. We have two neighbors and you can see both the neighbors are up, and receive route from both the neighbor is 0. Now you can see receive route is 1. From both the neighbor it is receiving one route. On router number 2, so IP BGP summary. Very good. You can see two neighbors 12.1 and 24.4. From 12.1 it is not receiving any route 0, but from 24.4 it is receiving one route. On router number 3 also we will have exactly same output, so IP BGP summary done. From this neighbor receive route 0, from this neighbor receive prefix 1, and on router number 4, so IP BGP summary. Very good. Receive route from both the neighbor is 0. So IP BGP in the BGP table you can see it have installed the 40.1.1.0/24 subnet, and next hop address is what? 0.0.0 because it is self advertised. Guys, here we are not able to see all the attributes. You can see wait attribute is what? 32768. Why? Because it is self advertised prefix. For self advertised prefix, wait attribute will be always 32768.
32768.
But on router number 2 it is going to be 0. Like on router number 2, if I will show you IP BGP table, you can see wait attribute is 0 because on router number 2 it is received route, and next hop IP address is 24.4. On router number 4, self next hop is 0.0 because it is self advertised prefix. Metric is also 0. Local preference value is 0. Wait attribute is this one. Origin code is I, and there is no any ES path. If you will open it in detail, like the BGP table, like if I am going to say show IP BGP and show me the detailed information of 40.1.1.0, right? So here you can see the detailed information. One path is there, and that is best. And after that it is advertising, yes. Next hop 0.0.0 submit is 40, and here you can see the attributes, all the attributes, right? Origin code IGP because I have advertised this network through network statement. Metric is 0. Local preference value is 100. Wait value is 32768. This prefix is valid and local connected network, and this is the best. Now let me take you to R1 router 1, and on router number 1, so IP BGP you can see two. It is receiving this network 40.1.1.0 from two neighbor, but this is only valid, not best. Who will tell me why this is not best from any of the neighbor?
Reachability.
Next hop.
Next hop, sir. Next hop. Next hop.
Reachability. Okay.
Next hop.
Apart from the next hop, you can see the another attributes like metric is 0. Local preference value is 100. It means we understood that for received route, local preference value will be always what? 100. Received route from the IBGP neighbor is 100. Here you can see both the neighbors are IBGP neighbor, so IP BGP neighbor, and then we can say include link. So you can see both are internal neighbor, internal link. Both are IBGP neighbor. Both are IBGP neighbor. So first attribute is next hop attribute, and next hop IP address is not reachable from any of the neighbor. And some other attributes are there, like you can see the ES path. ES path is 200. Because when router 4 will advertise the prefix to router number 2, it will include the ES number, because router 2 and router 3 are their eBGP neighbor. And you know the loop avoidance mechanism in case of eBGP. That's why on router number 4, you can see if I am going to open it in detail, we are not able to find any ES path attribute here. But on router number 2, here we have ES path. Even here on router number 2 also I can open it in detail, and you can see the ES path. AS path is not showing here, it is 200, right? And on router number 1 also you can see the AS path is 200 from both the neighbors, right? This is origin code, this is my weight attribute, which is 0, local preference matrix. Now next hop, guys, what I want, router 1 should install this 40 subnet in their routing table, in their BGP routing table via router number 2. So on router number 2, simply I will run this command, router BGP as number 100 and your neighbor 12.1.1.1 next hop self, right? For this neighbor next hop self, and on router number 1, if you will check the BGP table now, wait for some time, or you can clear the, you can send one refresh message, clear IP BGP star soft in and show IP BGP. Now you can see from this neighbor it is only valid from router number 3, guys, 34.3. From this neighbor it is only valid, not best, but from router number 2 it is best, right? Now best is via router number 2 because this next hop IP address is reachable, this next hop IP address is not reachable. If you will open it in detail, 40.1.1.0, and you can see the detailed information from both the neighbor. 2 available path. How many available paths are there? 2 available paths are there. And see some other attributes and the next hop. From 13.3, next hop is what? Next hop is 34.1.1.4, which is inaccessible, right? When it is receiving the route from this neighbor, this is what? This is the neighbor information, right? In the neighbor table you can see, so IP BGP neighbor summary. Here is the neighbor 13.1.1.3. So when it is receiving this route 40.1.1.0/24 subnet from 13.1.1.3, what next hop is coming? 34.4, which is inaccessible. And when the same route is coming from 12.1.1.2, then what next hop is coming? 12.1.1.2, which is accessible, reachable. That's why best is from 12.2, and here you can see the best keyword, right? You will not find this, you cannot see this best keyword here in the attributes of router 3. When router, these are the attributes with 40 subnets when router 3 is advertising, and these are the attributes with 40 subnet when router 2 is advertising.
So suppose there is both routes are best, then how can BGP will select the path?
Then it will check next attribute.
Okay.
Right? So now, okay, it is clear that it is selecting best path on the basis of next hop IP address now, right? How you will identify that? How BGP have selected the best path? By checking it in detail, right? One next hop we are able to see, one next hop is inaccessible, one next hop is inaccessible, right? So that's why show IP route BGP, you can see best is via 12.2. Now on router number 3 also I am going to run next hop self command, router BGP yes number 100 and neighbor 13.1.1.1. Now if anyone can tell me that how router 1 is going to select best path, that means you know the BGP attributes. Now you can see show IP BGP, show IP BGP, you can see still best is router number 2, and let me clear IP BGP star soft in and then show IP BGP. Now you can see still best is via which router? Router 2, but guys now both the next hop are reachable.
IP. Yes.
Now both the next hop are reachable. Then how router 1 have selected the best path?
IP address.
Lowest IP address.
Lowest IP address. So IP BGP 40.1.1.0. Best is this one. This next hop is best 12.2 via router number 2.
Oldest path of EBGP.
Both are IBGP neighbor.
Yeah.
Both are internal neighbor, not eBGP.
No.
So it is performing best path selection on the basis of lower neighbor router
Your
ID. On router number 2, if I will configure router ID, let's say 255.255.255.255, then let's say BGP router ID 255.255.255.255. Let's say 20.20.20.20, and now go to router number 1 and check the BGP. So IP BGP. So IP BGP. Now guys, best is via router number 3. Even it has not received the route via router number 2. Wait, so IP BGP summary. BGP is slow, it can take some time. Here is the neighbor 12.1.1.2 and received route is 0 from this neighbor. Wait, soon it will receive 1 dot from 12.2 as well. क्या हो गया?
सर बट एक क्वेरी है, पहले आईपी चेक करेगा बाद में राउटर आईडी चेक करेगा ना?
पहले राउटर आईडी.
ओके.
अरे यार अब तो राउट ही नहीं मिल रहा है तो उससे.
सर वो सिमुलेशन की वजह से हुआ होगा. तो सब तरफ ये सॉफ्ट रिबूट मारना पड़ेगा, अपना क्लियर करना पड़ेगा बीजीपी को.
Clear IP BGP star soft in and so IP BGP 24.4. ठीक है. Now on router number 1, so IP now it is receiving from both the neighbor, and let me show you the BGP table. So IP BGP, and you can see best is via which router again 12.2. तो आपका तो फेल हो गया वो लोअर राउटर आईडी कॉन्सेप्ट.
लोअर राउटर आईडी भी छोड़ दिया.
हाँ. So IP BGP summary. So IP BGP neighbor router ID is this one 20.20.20.20 here. कोई बता सकता है? Can anyone tell me?
ये पता नहीं.
Next hop, wait, local preference, self-advertise, ES path, origin code, made, internal over external, सारा कुछ same. All the attributes are same. मेरे हिसाब से यहाँ पे बेस्ट होना चाहिए via router number 3. So IP BGP. Clear IP BGP star soft in. So IP BGP
The lowest neighbor IP.
40.1.1. So lowest router ID.
Lowest neighbor IP will be the tiebreaker. Sir, at the last.
Router 3 has what router ID? Let me check that first. 0. So
13.1.1.3.
IP BGP neighbor. Router 2.
So
router 3 has router ID what?
13.1.1.3.
Yes, right. So on router number 2, I am going to configure router ID 40 or 50. Router BGPS number 100 and BGP router ID 50.50.50.50. And here clear IP BGP star soft in. And now on router number 1, check the BGP table. So IP BGP summary first. it is not receiving the route from R2. Clear IP BGP star soft in. So IP BGP on router number 2. So IP BGP summary. Okay, it is still taking some time. Clear IP BGP star soft in.
What does this SE means?
What I see?
Under prefix, it was showing SE, right?
No, this prefix is, guys, here only valid till now. It will take some time. So IP BGP summary. This SE.
Sir, this is
Yes, sir. Yes, sir.
See here. Somewhere you will find the full form. Anyone able to see? As is state, somewhere information should be there. The state send. When the BGP session will not established fully, then you will find this. And the full form, I cannot recall the full form of the SE now.
Okay.
But when the BGP session is not established, then you will find this SE in the neighbor state. The meaning of this SE is send state. It is send state. It is indicating the state of your BGP neighbor. It means BGP neighborship is not fully established. Okay, if is established and SAS means we will see what is the full form of SE. Okay, it means the neighbor is not fully established till now. Now receive prefix is 0. Clear IP BGP star soft in, and so IP BGP again. Okay, now 40 submit is coming, and go to router number 1 and check now. Summary, it is receiving the route from both the neighbor and so IP BGP. Now best is via which router? Now best is via router number 3 because of lower neighbor router ID. Because of lower neighbor router ID, right? So IP BGP neighbor, and I am saying include what router ID? Router only. Yes, here you can see the router ID of router number 2 is 50.50.50.50 and router ID of router 3 is 34.1.1.3. So router 3 has lower router ID, that's why it has selected best path via router number 3. Clear? Again, if I will remove this command from router number 2, best path will become via router number 2. This is an automatic process, right? But guys, in the production, you will never leave the best path selection on automatic process, on the automated, right? We will configure the best path on the basis of our requirement, on the basis of link properties, link bandwidth, delay, service provider, like the quality of link, which type of providers are there, on the basis of that. Right? Maybe one is MPLS, one is internet. This is MPLS service provider, this is internet service provider, ISP. And we have VPN over both the public network. So definitely we will prefer MPLS over internet for mission critical traffic. Okay, this is the default one. Now on router number 1, next hop is clear. Next hop attribute is clear. So IP, yeah, BGP. Best path is via router number 3. This time router 1 is performing best path on the basis of lower neighbor router ID. But what I want, best path should be via router number 2. Right? So lower neighbor router ID will be checked at last. Here, how we can configure path manipulation, how we can prefer router number 2 over router number 3. Let's use wait attribute. Go to router 1 and say router BGP 100 and your neighbor, when neighbor 12.1.1.2, and for this neighbor I can set wait value what? Let's say 100 and clear IP BGP star soft in, and now you can see so IP BGP best is via now router number 2. Why guys? Because of wait attribute. Here you can see wait attribute is 100 and here wait attribute is 0. So wait attribute via router number 3 is 0, wait attribute via router number 2 is 100. Right? So that's why it have installed it in the routing table now via router number 2. Clear? Here you can see the detail. Wait 100 from this neighbor 50.50.50.50 and wait is 0 from this neighbor 13.1.1.3. Hope it is clear. Right? So we have influence which type of route, the incoming route, right? Which is route which is coming from router 2 and router 3. And guys, the effect is going to be for outbound traffic, the traffic which will go in 40 subnet. Now, if a user is going to generate traffic, let's say there is one user on router number 1 whose IP address is 1.1.1 who want to forward traffic to 40.1.1.1. Router will check routing table, so IP route 40.1.1.1, and you can see next hop is 12.2. It will forward traffic to router number 2. 1 minute. Okay. Clear guys? Wait attribute. Now next attribute is my local preference attribute. I'm going to remove, and here let's do one thing. Let me create one loopback on router number 1 as well. Here we have loopback 40.1.1.0/24, and on router number 1 also I'm going to create one loopback 10.1.1.0/24. So now if 10.1 want to communicate with 40.1, my traffic will go via router number 2. See, router BGP 100, and here I am going to say network 10.1.1.0 mask 255.255.255.0 exit interface loopback 1 and IP address 10.1.1.1 255.255.255.0. Done. So IP BGP. Now you can see in BGP table 10 subnet is there, and on router number 4 you can see so IP BGP for 10 subnet guys 10.1.1.0 best is, which router is the best? Router number 3. Router 3 is the best path is via router number 3. You can see on router number 1 for 40 subnet best is via router number 2, and router number 4 best is via for 10 subnet best is via router number 3. So this is asymmetric path. When 10.1.1.1 want to communicate with 40.1.1.1, how traffic will go? And can anyone tell me how router 4 is selecting best path? How router 4 is selecting best path?
On the basis of router ID.
Hey, both are eBGP neighbor, bro.
Acha, then next hop. Sir.
Next hop?
Means
both the next hop are reachable. You can see. Oldest path.
Okay.
Oldest path. Right? First router learn this subnet and subnet from router number 3. If you will down router number 3 and again you will up, then best path will become via router number 2. Right now, if 10.1.1.1 want to communicate 40.1.1.1, how traffic will go? Router traffic will reach to router 1. Router 1 will check their routing table. So IP route and 40.1.1.1. Next hop is 12.2. So router 1 will forward traffic to R2. When R2 will receive the traffic, again R2 is going to check their routing table. Same command, it will use same command, this command, R2, and next hop is router number 4, 24.4. It will forward traffic to router number 4, and router 4 will forward the traffic to server, means my user, LAN user. 40 subnet is directly connected here. So IP route and 40.1.1.1. It is directly connected on loopback 1. Now loopback 1 will generate reply. In the reply message, source IP will be 40.1.1.1 and destination IP will be what? 10.1.1.1. Right? So it will check so IP route 10.1.1.1. Their routing table to forward traffic to 10.1.1.1. And next hop is 34.3. Router 4 will forward traffic to router 3 like this. And then router 3 will forward traffic to router number 1. So we are using asymmetric. This is asymmetric routing. Request is going via router 2, reply is coming via router number 3. Right? For outgoing traffic from site A to site B, right, best path is via router number 2. How we have configured this path? This path should be the best path because we have configured higher weight value for 40 subnet via router number 2. That means if we are receiving the best route here, then my all traffic will go via this path. And on router number 4, the 10 subnet is coming from router number 3. Best is from router number 3. That's why traffic is going from this path. What you want? Router 4 should always forward traffic via router number 2. Right? Can I advertise higher weight value to this neighbor, to router number 2? No. It does not carry weight information in the update message. Guys, you can see here on router number 1, first of all, one more thing I want to show you. What I did, router BGP 100, and I said neighbor 12.2 weight value 100. I am going to remove this command. And I can do same thing with the help of route map as well. I can create one route map, with name, let's say weight, with name weight permit sequence number 10, and in this route map I can say set weight value what? 100. And then I will apply this route map with BGP neighbor, router BGP 100, and I can say neighbor 12.1.1.2, use route map. Which route map? Weight route map. In which direction? In direction. In direction. That's it. Both are going to do same thing. Clear IP BGP star SOP in. So IP BGP. Again you can see here we have weight 100. For 40 subnet. Right? But if you apply it in odd direction, router BGP 100 and weight out, means what I am saying, whatever prefixes you will advertise to this neighbor, use route map weight, right? And then you can see we are getting error. What happened? Weight use as okay. So first of all, let me say no to okay. Why we will remove? You know this, that we cannot apply it in odd direction. Even if you will apply it, command will work, but router 2 will have the default weight value 0 only. Right? Now another thing, first of all, on router number 4, it is performing best path by default on the basis of oldest path. How we can prove it? We can prove it by shutting down this neighbor. A router BGP is number 200, and I am saying neighbor 34.1.1.3 shut down for an example. Shut down. And now do so do show IP BGP. Now you can see best is via 24.2 router number 4, and again I am saying neighbor no shut, no to this command. Again the neighbor will come up with show IP BGP summary. Again neighbor is up, show IP BGP. Now you can see best is via which router? Router 2. Right? So it is selecting best path on the basis of oldest path. Will you leave the best path selection on the oldest path, guys? Sometime your internet can be best, sometime MPLS can be best. Right? No, we will not leave it on the default. We will configure attributes. Right? So what I want to receive traffic on router number 1 from router number 4 via router number 2. Right? Means we are going to influence outgoing routes, or you can say incoming traffic. If I want to receive traffic from router number 2, I have to advertise best route via router number 2. Yes, na? Then local preference attributes comes in picture. Now let me tell you the local preference attribute first, and then we'll move further. Local preference, so important attribute, local preference. This is open standard attribute, and BGP always carry this attribute in or local preference information in its outgoing update message. In their outgoing update message, but only for IBGP neighbor, only for IBGP neighbor. For EBGP neighbor, it will not carry the again with local preference value. Right? And what is by default local preference value? See here, on router number 1, so IP BGP, guys, for 10 subnet, 10 is self-advertised prefix, local preference value is 0. But for 40 subnet, you can see local preference value is 100 from both the neighbor. And on router number 4, so IP BGP, you can see for 10 subnet, local preference value is what? 0. Why? Because it is receiving from their EBGP neighbor. It is receiving from their EBGP neighbor. So BGP does not advertise local preference value to EBGP neighbor. Again, local, like wait is an attribute which is used to influence incoming route. It is local to the router. On one router, if you want to perform path manipulation, then you can use wait attribute. Not in the multiple router. For an example, let's say this is my company network. This is my company network R1, R2, R3 and R4 connected like this, and connected to 2 service provider. What I want, and through service provider, here I have DC data center 10.1.1.0/24 subnet is there, right? So both the service providers are advertising this subnet to my company. This is, let's say, PM net, right? What I want to prefer ISP1 to reach data center. So here I will configure wait value what? 100 for an example, 100 or 200, 500, doesn't matter, any value. But it is not going to propagate to router number 1, right? Or router number 4. Maybe router 4 will forward traffic via ISP2, because this is local to the router. It will not advertise to their neighbor. Maybe router 4 will be forwarding traffic via ISP2. So if I want to influence the route in my entire company, like on all the routers, wait attribute cannot do it. This is local to the router. This is limitation of router. That's why we have so many other attributes. Similarly, what is the limitation on local preference? Through local preference, you can manipulate or influence the routes or traffic for your IBGP neighbor only, right? Means it will influence the routes within the yes na, yes, and by default value is 100. By default local preference value is 100. By default value is 100. You can see for all the IBGP, all the routes which routers are receiving from their IBGP neighbor, you will always find local preference value 100. On router number 4, we are not able to find any local preference value for 10 subnet. On router number 2, so IP BGP summary, you can see, sorry, not summary, only BGP. I want to see the BGP table. See, for 10 subnet local preference value is 100 because it is receiving from IBGP neighbor, and for 40 subnet local preference value is null, nothing, right? And higher value will be always prefer, right? Guys, in future, right, when you will learn the SD-WAN or advanced technologies, you might have heard about OMP protocol. OMP, overlay management protocol in the SD-WAN. There also we have local preference value. We have exactly same concept like BGP. In the OMP, if you want to perform path manipulation, there also you can use local preference. You can configure higher local preference value from one side. You can advertise higher local preference value from one neighbor. Right, so higher value will be always preferred. By default, local preference value is 100, and BGP will always carry local preference attribute for their IBGP neighbor, which is by default 100. Hope it is clear. Clear, guys?
Yes.
In case of default local preference, BGP will not compare it for best path selection. Even BGP is not going to use local preference. Otherwise, you can say that Praful, let's say I have one router here, R1, connected to R2 and connected to R3, another neighbor. Both the neighbor are advertising one subnet, X subnet, and let's say here ES number is 100, here ES number is 100, here ES number is 200. So one is IBGP neighbor, one is EBGP neighbor. Router 2 will receive X subnet from R2 with local preference value 100 and from R3 with local preference value 0. So it should perform best path selection to reach in X subnet on the basis of local preference value. Here we have higher local preference value, best path will be router number 2. No. 100 is the default value. Router will never compare the default local preference value, right? It is going to check next attribute this time. It will check next attribute, self-advertised attribute, and so on. Default local preference value will be not checked for best path selection. Okay. Now, if you will set local preference value 101, then it will work, right? So guys, see here what I want. That one more thing. Can I ask you one easy question? On router number 2. On router number 2. Let me just test your knowledge, existing knowledge. So IP BGP. See 10 subnet. How many paths are there to reach in 10 subnet from router number 2? How many paths are there?
2 paths, I guess.
2 paths. Why I am not able to see both the path here in the BGP table? Huh?
Only the best path will show
I
up here.
think because
BGP टेबल में तो सारे पाथ दिखेगा ना यार, राउटिंग टेबल में ना बेस्ट पाथ दिखेगा. आप आंसर ना करो ना तो कभी थोड़ा मुझे चलता है. आप ऐसे गलत आंसर करते हो, दिल दर्द देता है यार दोस्त. कितना बार हम लोग ये लूप अवॉइडेंस EBGP में पढ़े हैं कि अपना ES नंबर आएगा तो ये इंस्टॉल नहीं करेगा, एक्सेप्ट नहीं करेगा. जब इधर से घूम के आएगा
Strict horizontal. Same
from
here
this
से आएगा
side, there will be their own ES number, right?
Yes, sir.
So these are the basic things. I am expecting you should think about these multiple paths, why it is not installing from, because in the BGP table we are expecting all the path. In the routing table, best path, right? So you should check the default behavior. By default, why best is via this router, or why alternate path is not showing in the BGP table, right? Like here, if I will run command allow ES in from router number 4 for this neighbor, we will have the alternate path as well via router number 4, right? But that can be loop, then that is loop. Here we can create the loop. Then in this case we will never allow ES in. Okay, on router number 2, here we have local preference value what, 100 for this subnet, right? I want to set 200 local preference value. Config T, route map LP, local preference permit sequence number 10, and set local preference value what, 200. Exit router BGP S number 100 neighbor 12.1.1.2 and route map LP direction out, and go to router 2 and say clear IP BGP star soft in and show IP BGP. Local preference value is 200, but on router number 4 show IP BGP. कोई local preference है? No, there is no local preference value, right? So through local preference value we can note influence the which route, outgoing or incoming between router 1 and 4, incoming or outgoing route. Outgoing route, what I want, router 4 should install, let's say 10 subnet via router number 2. Router 4 should install route via router number 4. Router BGP 100 200. You can see we cannot run more than one process of BGP on router. Like you can run multiple processes of OSPF on single router, but not multiple processes of BGP. BGP need, guys, use memory. Neighbor 24.1.1.2 shutdown, and then say no shutdown, and now you can check again show IP BGP. Now again best path is via router number 3. But what I want, router 4 should install this path via router number 2. But you are not allowed to configure these service provider routers, or maybe you don't have access of this DC router, right, somewhere else. So from router number 1 only, how you can manipulate the path? We can use the next attribute. Guys, should I discuss this attribute, self-advertised attribute? Now see, next hop is clear, wait attribute is clear, local preference attribute is clear.
Sir, by default, all the attributes not taking, like local preference is 100, weight is 0.
Weight is 327684 self-advertised prefix.
So local preference is not taking, like for attribute, right?
It is
by
taking,
default.
na? For IBGP neighbor it is taking.
It's 100, right?
Yes.
By default.
Yes.
When we have to manipulating other router with the 0, it will not taking, right?
Advertise with 0.
Suppose we are doing R2 in local preference is 100 and R3 with 0. But BGP is not taking.
No, no.
So what I am saying, it is affect to other all the.
By default, your best path selection is going to happen on this tiebreaker here. For eBGP oldest path, for IBGP lower neighbor router ID in this case, right? Here I can do one more thing on router number 4. See, best path is via router number 3. I want best path via router number 2. So locally I can add the local preference value here. Route map LP permit sequence number 10 and set local preference value, let's say 200 or 150, and I can apply it in direction for router number 2 neighbor. Router BGP ES number 200, neighbor 24.1.1.2, and route map LP and direction in, and clear IP BGP star soft in, and so IP BGP. Now here local preference value is 150 when it is receiving from 24.2 means R2. That's why you can see now best is via R2, right? So now all the traffic will go from this side as well as all the traffic will come from this side, right? These are the basic attributes, guys. Generally you will be not using these attributes. These attributes are used within the enterprise, within the company, within the ES, right? Even the weight attribute is local to router, right? Your main attribute is here, which is the most common attribute in the production.
Yes, sir.
ES
So
path.
from ES path we can also do path prepending.
Yes, path prepending only. Like from router number 1 only, I can manipulate the routing table of router 4. That router 4 should install this 10 subnet from router 2 or from router number 3. You can do it from router number 3. How? I will advertise 10 number of ESA from this side and 2 number of ESA from this side, let's say. So automatically best will be this one, the lower ES path, right? So now see, weight is clear. Okay, weight is clear. Next hop is clear. Local preference attribute is clear. Self-advertise, no need to discuss. Self-advertise means if our BGP router is receiving same prefix which it is advertising, then it will always prefer the self-advertise. This is common, right? Means 0.0.0 next hop will be always preferred over any other next hop, right? And you know, for self-advertised prefix, next hop will be 0.0.0. So 0.0.0 next hop will be always preferred over any other next hop, okay? Now next attribute is my ES path. So in the next class we'll see the ES path and origin code. Even origin code is not so important, but you will understand. Then metric, these two are so important attribute now, ES path and met. After that, external over internal, it's very clear with their name only. IGP cost to reach next hop, it is also clear, okay? And these are the, you already know about the oldest path and lower neighbor IP or lower neighbor router ID. So what you guys need to do, you guys need to design this topology in your EVNG or maybe in your GNS3. Let me show you this one for the path manipulation. For the path manipulation, this is also fine. But if you want the real-time scenario, then just take a screenshot of this lab and create it in your EVNG or GNS3, right? Here we will use all the attributes for path manipulation. Okay, 2 sides are there and 2 service providers are there in between my 2 sides, right? You will be not allowed to configure access service provider router, so you have to manipulate the path between this side and this side by configuring your router. Within the company, path manipulation is so easy, right? By using next hop or weight or local preference value attributes. it is going to be very easy. Yes, no guys?
In production, which attribute is commonly using, sir?
ES path.
Yes, path.
Both AS path, local preference.
Local preference, yes. Local
Yes,
preference, ES path, MAD, metric. MAD attribute is also used. So it's useful attributes.
And sir, there is also one thing like
Binay, go ahead. Yeah.
like forwarding path is different and reverse path is different sometimes.